All right, guys. Good evening. Welcome, all of you. Okay. Yes. Am I audible to everyone? Okay, chalo. So let's now begin. So basically, yes. So you're going to see me Friday and Sunday, 6 p.m. And as you all know, that in the special classes, what we are doing is, and the special class was 5 p.m. today itself. Okay, so special class, free class on Unacademy 5 p.m. पे हमने क्या पढ़ा? We had studied elimination reactions today, and we have discussed like really important topics. Okay, so what you are going to do is you can just visit an academy's website and select CSIR-UGC NET. From over there, you can search my name, Jagriti Sharma, and here you're going to get my plus courses as well as free classes, right? So my name is Jagriti Sharma, and I'm a CSIR NET educator since the last 3 years, and I have qualified all of these exams, as you can see: CSIR NET, GATE, and IIT JAM. Okay, and the courses that you're going to see right now on my profile is one of them is on the organic chemistry reactive intermediates. Okay, and the other one is complete inorganic chemistry course, and we have already completed chemical bonding in this course. All right, chemical bonding is already completed, and we have started coordination today itself. Okay, so if you want to join, you can join me on an Academy Plus. There will be more courses, right? These are not the only two courses we are going to finish. There will be more courses and more practice. Okay, you can join me for on an Academy Plus whenever you want. तो ये देखो आप क्या देख रहे हो? There are 18 special classes. These are all free classes. Okay, there are 18 free classes, special class on an Academy on a very important and scoring topic of organic, which is reaction mechanism. So I'm completing this topic in free class. So this is extremely important. This is the first time I am providing all the important examples and material for this topic in free classes. This must not be skipped. आपको आना ही है और पढ़ना भी है यहाँ पे. Free class है guys. Share भी कर दो सबसे. Okay? Yes. Also, all right. Also, just after these sessions, okay, तो हमारे session free classes कब कब होते हैं? Thursday, Friday, Saturday, and Sunday. These 4 days we are having, 4 days of the week we are having the special class 5 p.m. Okay. All right. And जिसमें से Friday and Sunday we are going to have the YouTube session. Okay, Friday and Sunday, 6 p.m., you are having the YouTube session. We have already had a session on starting with a strategy for your exam preparation for the 3 months. And right now, we are on to this session practice on reaction mechanism, first part. Okay, so this is the first session that we are going to do on the practice question. Chalo, jaldi se start kare. What do you say? Let's begin. All right, question number one. The relative rate the relative rate of solvolysis the relative rate of solvolysis of iodides are over here. All right. So what is the correct order? Which is the correct option? Okay. Which one is the correct order? Sure. So you say C, B, and A. Is it? See guys, see the structures properly. In option number B, we have an sp2 carbon. What is solvolysis? Solvolysis will either undergo backside attack SN2 or most probably it is SN1, right? So please pay attention to what is given over here. We don't want to do a simple question wrong, right? बहुत ही simple सा question है. Yes, absolutely. This is going to be option number A. Why? देखो, in option number C, you know that there is going to be NGP. There is going to be NGP, and I have told you that when you are forming, NGP भी हमेशा नहीं होता है, isn't it? NGP will only happen when the ring size is a proper stable size, right? So here you are forming one, two, three, four, five. Five-member ring you are forming, and that is why NGP could happen, and it's going to make the solvolysis faster. Very well. So the reason for option number C is NGP. Okay. What about option number B and A? See guys, if the iodide is lost from here, what would you get? You would get a sp2 carbocation like this, which is absolutely unstable as compared to a simple carbocation like this. So double bond ke upar positive charge is not stable, isn't it? Yes, sp2 cation not stable. So who is going to be faster, A or B? Definitely A will be faster. So that is why this is your correct answer. Yes or no? Now makes sense? Yes. दूसरे स्लाइड पे चलते हैं फिर. Okay. So next question is, all right, and also guys, you are not going to get any PDF in the YouTube format. Special class में तो क्या होता है? You get the PDF also. You can download a PDF, but here you're not going to get the same. If you want, you can take a screenshot or note it down quickly. Done, right? Let's move onwards then. Question number 2. Again, you have to say the major product. Guys, बहुत अच्छे अच्छे examples हम practice करने वाले हैं. So follow all these YouTube sessions along with the special class so that the continuity does not break. Okay, continuity of this one topic does not break. Reaction mechanism in free classes, reaction mechanism practice on YouTube. Alright, you have some reagent like this. और आपका product जो है वो क्या होगा इनमें से? That is your question. It is too easy. You just have to pay attention. All right. So which one is your correct answer? For every question, you are maximum going to get 2 minutes. Yes, Anusha, this is our first practice session और ये second question है first practice session का. Okay, Anusha, all right. Yes. So are we done? Yes. What is the correct answer? All right. B. Maximum B. चलो. Very well. So what is the thing which is followed? क्या rule follow कर रहे हैं यहाँ पे? Right? This is your simple SN2 reaction, isn't it? You are having a nucleophile which is your sulfide. Okay, very well. Where is it going to attack? Now, just looking at this structure, you will say कि मैम both side attack is possible. यहाँ पे भी हो सकता है, यहाँ पे भी हो सकता है. But no, when we draw this in the chair conformation, and what chair is it? Is it the trans chair? Methyl above, hydrogen below. Yes, it is your trans chair conformation. और oxygen कहाँ है? Oxygen ऐसे है. Yes or no? The oxygen is like this, the epoxide is like this, both of the bonds above the plane. Okay. Now, as I always say, a diaxial attack will be more favored or a diaxial product will be more favored. So where would you have the axial attack? Over here. यहाँ पे होगा axial attack on this side. This is correct, this is wrong. You don't want a equatorial attack. So this is your axial attack and this is equatorial attack, right? So an axial attack is more favored as compared to the equatorial attack और इसीलिए you are going to get the nucleophile that is your sulfide over here and the OH over here which corresponds to option number B. ठीक है? Yes. This is your major product. All right, very well. Everyone understood? Just try to draw this by yourself, guys. Okay? Chalo, let's move on to the next question. Super nice question this was. अगला question है among the choices among the choices the correct statement for the product is the correct statement for the product is all right. So there it goes. This is what you have. See, the product is also given to you. Product is also given. ऐसा नहीं है कि product नहीं दिया, you have to find the product. But product stereochemistry is not given. Product दिया है, product stereochemistry is not given. So stereochemistry is asked. A is a single enantiomer. A क्या है? जो product है हमारा A is a single enantiomer. All right. Option number B says A is a racemic mixture. Option number C says A is a mixture of two diastereomers. A is a mix of two diastereomers. और final option हो गया A is a mix of two epimers. ठीक है, जिनको एपिमर पता है बहुत अच्छी बात है, जिनको नहीं पता है दिल भी स्कैर्ड कि अरे बाप रे ये क्या पूछ लिया. All right. Yes. All right, Shoaib, have some patience. अच्छे से करो. A is a single enantiomer. A is a racemic mixture of two diastereomers, mixture of two epimers. See, reaction mechanism तो सबको आता है, पर स्टीरियो मुश्किल हो जाता है ना. This is where we get stuck in the exam. Because we know that this is a simple SN2 reaction. Epoxide ring opening by a nucleophile. Yes. So with these examples, you have to be extra careful. Guys, I want all of you to reconsider your answer. Okay? There is no hurry. We are here to practice. अभी आधा घंटा और है अच्छे से और पूरा महीना reaction mechanism practice करेंगे, right? There are 8 sessions for practice. No hurry at all. So reconsider your answer once. Try to draw this. हाँ अभी ABCD करके सब बोल दो. Anyone will be the answer, right? Okay. This question has been asked in your CSIR exam June 2012. All right. चलो ठीक है. Let's try this out. Yes, let's try this out. What is happening? So, this is a nucleophile. Let's just consider that the nucleophile is Nu. Let's keep things simple. Okay. Nu ने attack किया, backside attack किया, यहाँ पे. So the ring opens up from here. What is the product that you get? You get this product. Okay. O minus, it will be OH like this, nucleophile like this. Okay. Similarly, when the nucleophile attacks over here, this side going to open up, what is the product that you get? This side OH, this side nucleophile. Now when you say diastereomer, when you say the product is diastereomer, मतलब आप एक चीज की रट पकड़ के चल रहे हो कि when there is already a chiral center और एक नया chiral center बन गया है, when there are two chiral centers it has to be a diastereomer. Not necessarily. That happens in the case of carbonyl attack. Yes or no? Prochiral carbon है, already existing chiral carbon है, so if you get one new carbon via some reaction, one chiral carbon via some reaction in the presence of another chiral carbon, then you get diastereomer. यहाँ तीन chiral carbon हो गए हैं, 1 2 and 3. Yes, right? So there are three chiral carbons over here. You cannot go by that way. What you have to do is, guys, product बन गया, just rotate this a little bit. इसको कर दो 180 degree rotation. When you rotate this, it's going to be like this. Just rotate in the plane of paper. Plane of paper मतलब कि if this is your molecule, just rotate it like this, ऐसे करके. Okay? So here it is. The hydrogen is still above, tertiary butyl still below. ये OH लेकिन यहाँ आ गया है. And this nucleophile has come over here. ठीक है? So tell me, are both of these mirror images of each other? Yes or no? I have actually kept it in a slanting position, but try to imagine this in in front of each other. Yes, try to imagine this both of these in front of each other, then you will be able to get it properly. Right. So they are not superimposable. आप सोचोगे कि आप इसको superimpose कर दोगे, नहीं करोगे, नहीं होगा. They are non superimposable. Just check this and this. इन दोनों को check करो, दोनों products को. They are non superimposable mirror images. So 50-50% of both the enantiomers when it is formed, it is a racemic mixture. And also tell me, I am like 100% sure कि 50-50% ही बनेगा. Yes. Why? Because there is no such barrier कि one-sided preferential attack हो. Isn't it? Both of this nucleophile can attack at both positions equally, right? तो इसीलिए 50-50% होगा. This is a racemic mixture that you get. Yes or no? All right. So does it make sense to you? Please try to draw this by yourself. It's a very, very nice question. Okay. Yes. और अगर नहीं नोट डाउन किया है तो एक बार फटाफट इसका स्क्रीनशॉट ले लो. Tertiary butyl, no effect. No, tertiary butyl is not going to affect over here because first of all there is no reaction on that center. शोएब उस carbon center पे कोई reaction ही नहीं हो रहा है. दूसरी चीज, this is not a chair conformation that you want to lock it in one conformation and then move onwards. ये chair conformation भी नहीं है, 5-member ring है. Okay, so that is why it is going to be a little bit different. All right, you are just going to keep the chiral carbon as it is. No change over there. Chalo fir. All right, let's now do another question. Question number 4. Okay. Question number 4 we do. Question ऐसा है. Among the following dibromocyclohexanes, the one that reacts fastest, the one that reacts fastest with sodium iodide to give cyclohexene is अब ये सोडियम आयोडाइड जो है, दिस इज नॉट गोइंग टू गिव यू अ सब्स्टिट्यूशन रिएक्शन. वेरी एविडेंटली साइक्लोहेक्सीन बन रहा है प्रोडक्ट, सो beware of this. There is no substitution taking place. All right, very well. These are some really simple and very good examples which are going to bring more clarity to all of you on this topic of reaction mechanism. बहुत अच्छे अच्छे questions हैं. Yes, these are all free for you. Also, I am conducting, once again reminding you all, for those who will watch this session later on as well, please also follow the special classes on Unacademy. Right? Special classes are free classes. Okay? Or we are conducting reaction mechanism topic completely for free this time. So don't miss those classes at all. Yes, so this is a very simple question. और ये हमें आ भी गया है. Most of the answers that I see are correct only. Yes, right. We are discussing all the aspects of these reactions, the stereochemistry, the leaving group, the nucleophilicity, everything we are discussing in the special classes. All right, guys. Yeah, this was a very simple question. तो ये बहुत ही अच्छा और simple सा question है. Let's see what's going on. Among the following dibromocyclohexanes, the one that reacts fastest with sodium iodide to give cyclohexene is. Okay, so I want cyclohexene by elimination with iodide. Iodide base है क्या? बिल्कुल नहीं है. Iodide is not a base. But I am not removing a proton either. I am removing a Br positive. Yes or no? ये देखो. One Br is above, another Br is below. I am removing a Br positive ion over here. ये इस तरीके से anti periplanar position पे है. This is the best position for the elimination to take place. Either you draw the molecule like this, or you want to draw the molecule in this way, or you want to just simply draw the molecule like this, cyclohexene. Okay, so C is your correct answer because I minus is attacking the bromine over here. Is it possible, guys? CBr bond के ऊपर attack किया iodine ने, Br ने electron density carbon पे leave कर दिया. How is that? Yes, how is that possible? That is possible because first of all, bromine is polarizable. Yes or no? Bromine is polarizable. Can this reaction happen for iodine? Yes. Can the same reaction happen for carbon iodine bond? Yes or no? Tell me. Can the same reaction happen for carbon iodine bond? Yes or no? मतलब कि can I conduct the same elimination reaction with sodium iodide if it was a carbon iodine bond, not a carbon bromine bond? Yes, absolutely I could do that because iodine is even more polarizable than bromine. Yes, but can I conduct this reaction अगर CCl bond होता तो? Would it be possible if I had the CCl bond over here? Cl above, Cl below, elimination by iodide I minus. अगर Cl होता या CF होता, would it be possible? No, yes, absolutely. These two would not be possible because they are not polarizable enough to do this reaction. Okay? Not polarizable enough to do this reaction. Okay. Yes, very well. Understood this concept. Now we move onwards and we do question number 5th. तो गाइज दिस इज आवर फर्स्ट प्रैक्टिस सेशन, और भी बहुत सारे अच्छे अच्छे सेशन होने वाले हैं. सो ट्राई टू अटेंड ऑल द यूट्यूब सेशंस लाइव. चलो, लाइव का मजा ही कुछ और है गाइज. If you have any questions, you can ask me as well. See, this is an awesome question, and इसमें थोड़ा टाइम भी लग सकता है आपको. Optically pure isomers A and B. Optically pure isomers A and B were heated with sodium azide, NaN3, sodium azide in DMF. Alright, so you know what is the role of sodium azide in DMF. What you have to do is choose the correct statement. What you have to do is choose the correct statement. Alright, here it goes. You have four compounds A, B, C, and D. Let me just draw all of them for you all. NMe2 above, Br below. This is A. और देखो, मैंने आपको बताया था इन द रिएक्शन मैकेनिज्म स्पेशल क्लास, आई टोल्ड यू दैट देयर विल बी क्वेश्चंस फ्रॉम CSIR नेट, जो कि सिर्फ ये नहीं पूछता व्हाट इज द मेजर प्रोडक्ट, वो ये भी पूछेगा विच इज द मेजर प्रोडक्ट, इज इट प्योर, इज इट रेसिमिक मिक्सचर, yes, how fast is it formed, which one is faster, which one is slower. Yes, we had discussed this thing, right? The same we are practicing over here. All right, this is also above, the azide is still above over here. So this is option number D. Now these are A, B, C, and D. You're starting with A and B, and C and D are your product species. देखो, यही वाला क्वेश्चन मैंने बताया था स्पेशल क्लास में. So the statement is A gives A gives optically pure A gives optically pure D, and B, that is your reagent B, gives optically pure C. मतलब कि A on reaction will give you optically pure D, and B will give you optically pure C. This is what the first one means. I'm not saying it's correct. Alright. A gives racemic mixture of racemic mixture of C, and B gives optically pure C. Okay. Third option, A gives optically pure C, and B gives racemic mix. ऑप्शन नंबर डी को हम लिख देते हैं A gives pure D, and B gives, okay, B gives racemic mix of C, यहाँ पे लिखेंगे B gives racemic mixture of D. Okay, yes, this is going to take some time. It might take 10 minutes right now for you to solve it, but in the long run, when you are solving plenty of examples like this, it will be done in 2 minutes. Yes, I want you all to at least draw the chair conformations of all of these. ये तो question है, इसमें chair conformation बनाना ही पड़ेगा. Reaction mechanism including stereochemistry. There is nothing without stereo, guys. All right. It is a big question. Are we done? Done. बताओ आंसर बताओ योगेश. Okay, very well. Yes, guys, honestly, give all your answers in the live chat. All right. So, yes, the correct answer is option number B. But let's first try out how it's happening. Okay. Optically pure isomer A and B were heated. See, I told you in the plus class, in the special class, that A B will give C and D. ये इस तरीके का question आता है, that which is going to give C, which is going to give D, like this or like this. What is the possibility? And if your product is like pure or racemic mixture like that, everything you will get. Okay. So let's start with A. Alright, we're starting with A and this is your compound A. Alright, now heated in azide in the presence of azide and DMF. ये क्या situation है azide and DMF? Is it going to give you SN2 reaction? Azide is your nucleophile, DMF is your polar aprotic solvent, going to give you SN2 condition. Yes, alright. Yes, Jatin एक बार refresh कर लो. Okay, so now just try to draw this in a proper orientation. Let's say this is your NME2. Let's say this is your bromine. Are they in the absolute anti-periplanar position? Yes. See, I'm not drawing the more stable one. मैं डाई इक्वेटोरियल नहीं बना रही हूँ. डायरेक्टली आई एम मेकिंग द डाई एक्शियल वन, क्योंकि हमें इसी की जरूरत है. Because we want to see if it undergoes NGP. Yes, it does. It undergoes NGP, NME2, one more bond and positive charge. Br minus is free. So this is your intermediate. This is your intermediate, and the azide can attack from two positions. It can attack from here, which will give you the diaxial product, which will give you the diaxial product like this, and the azide can attack over here as well, which will give you the di-equatorial product. Yes or no? ये NME2 फिर चला जाएगा equatorial के ऊपर. Okay? Yes. See, there is one thing that I had also mentioned, that you are not going to get equal possibilities of attack over here. SN2 attack की equal possibility नहीं है. This attack is more favored. The diaxial product is more favored as compared to the equatorial product. Yes or no? Because of the proper orientation of orbital. ठीक है, मान लिया. तो फिर racemic mixture क्यों आ रहा है question में? How are you going to get racemic mixture of anything? Racemic mixture तो 50-50% होता है ना. Yes, you are not getting 50-50%, but still since you are getting two products, तो इसीलिए हमें वो option भी consider करना पड़ेगा. All right, now flip this. This is product number A, this is product number B. इसको flip करो. So NME2 goes above. This is N3. This is NME2. All right. So sorry. So this goes above ऐसे करके. Now there is one thing that you also want to see. इसको कर दो rotate like this. ऐसा 180 degree rotation. And what is this rotation called? Out of the plane rotation. ऐसे करके rotation कर दो. Alright. So we are going to do out of the plane rotation for this molecule by, let's say 120 degrees. 1 2 3 तीन कार्बन से जब भी मूव करना होता है, you do 120 degree rotation. 120 degree rotation moves by 3 carbons. So the system is still like this. This carbon with the amine group moves over here, and this is going to move over here. All right, the azide is going to move over here. Okay, so if you are able to see this, ये दोनों क्या है, mirror image है. यहाँ से भी आपको वैसे समझ में आ जाएगा. These two are mirror images of each other, right? Just rotate and put this in the in front of A. You are going to see कि these two are mirror images of each other. ये बनाने की जरूरत भी नहीं है. All right, let's just remove this. These two are mirror images of each other, as you can understand directly. तो mirror images है, 50-50% में नहीं है, but still mirror images है. और ये कौन सा compound है? Let's see. Let's write it like this. It is NME2 above और azide below. ऐसा कहाँ पे है? ऐसा है option number C में, right? So this is your correct answer, that A gives racemic mixture of C. This part is correct. A gives racemic mixture of C. What about B? Now B is a very simple molecule. B is a very simple molecule like this, and the Br is above. There is no NGP possible over here. तो अगर NGP possible नहीं है, then the azide is simply doing a SN2 attack. Azide is simply doing an SN2 attack, और SN2 attack करने के बाद में it is going to still give you the same product, trans compound. Still it is C, but it is going to be pure C. It is going to be pure C. Okay, so A gives racemic mixture of C, you are going to say, and B gives pure C. All right, now this was your correct answer, option number B for this question. All right, I hope that this had made sense to all of you. अब ना एक और बहुत अच्छा question है which was asked in your GATE examination. Let's do that. Question number 6. Among the following bromides, among the following bromides, the order of reactivity, the order of reactivity specifically in SN1 reaction is, ठीक है, See, right now in the special classes, we have completed the substitution reaction, and that is why we are focusing on doing maximum substitution reactions. Okay. और इसका guys, इसका assignment भी ready हो रहा है. So you are also going to study, practice from the assignment as well. And we are going to discuss the questions, the doubts in the plus doubt clearing session. Okay. Like this. Option number 3. So which is going to be the correct order? 3 greater than 2 greater than 1. It's going to be 2 greater than 3 greater than 1. 3 greater than 1 greater than 2. ऑल राइट यस योगेश, लेकिन जो नए स्टूडेंट्स आए हैं उनको पहले सिंपल तो करने दो. और अभी एक ही टॉपिक कंप्लीट हुआ है ना. सब्स्टिट्यूशन, एलिमिनेशन इज देयर, द एडिशन और बाकी इलेक्ट्रोफिलिक सब्स्टिट्यूशन, न्यूक्लियोफिलिक सब्स्टिट्यूशन, एवरीथिंग इज रिमेनिंग राइट. जब सब कुछ हो जाएगा, we will have all types of questions. And then there is assignment. Wait for the assignment also. You will have all types of questions. Yes. So SN1 reaction में what is the order of reactivity? Very simple question. SN1 बोलो, solvolysis बोलो, everything is the same, right? गेट का क्वेश्चन है, बहुत सिंपल क्वेश्चन है. All right, everyone answers C. Okay then, C is your correct answer. All right. Chalo, let's try to answer this question. Among the following bromides, the order of reactivity is C. Very, very simple. Order of reactivity via SN1 reaction, if we need to find out carbocation stability, we are going to check. Alright, yes, we are going to check carbocation stability. Okay, then let's try to see that which carbocation will be most stable. One का carbocation कैसे बनेगा? It's going to be an allylic carbocation, right? 2 is going to be a diallylic carbocation, but भले ही diallylic हो लेकिन ये unstable हो गया है because of anti-aromaticity. Yes or no? You are having only 4 pi electrons over here, right? So this is going to be anti-aromatic system after the removal of bromine. Anti-aromatic is not stable, so 2 is going to be least reactive. Yes. And if we compare option number 3, ये क्या हो रहा है? Possibility of NGP. Yes, right? NGP की possibility है. Although the ring is like too small for NGP, NGP के लिए the ring is too small, so we won't go that way. ठीक है, NGP नहीं करवाएंगे, हम क्या करवाएंगे? Resonance stabilization. Okay, we will say it is resonance stabilization like this. A better option, isn't it? Yes, ये इसका reason हो गया है aromaticity. Proper reason is aromaticity over here, right? So chalo, what we will say is 3 is most reactive because of aromaticity, 2 is least reactive because of anti-aromaticity. बीच में कौन सा है? The allylic carbocation. So your answer is option number C. Okay. लेट्स डू वन मोर क्वेश्चन गाइस. 7 क्वेश्चंस करते हैं आज फर्स्ट सेशन में. 7 क्वेश्चंस. ऑल राइट. ओके, सो लेट्स मूव ऑनवर्ड्स. ओके, easy question. The product of the following reaction is product of the following reaction is there's a double bond, there are two methyl groups over here, it is reacting with HCl. What will it give? ये हमने अभी अभी पढ़ा है in the reactive intermediates plus class. So I hope that you will be able to answer. This is not a substitution reaction, but then I gave this to you because we have done similar reaction in NGP also. All right. All right, चलो. यस योगेश, वो एक तरफ घुमाने की आदत हो गई ना मॉलिक्यूल को. दिस वन वे रोटेशन. ओके, चले. लेट्स डू द आंसर. वेरी सिंपल. So here let's say you have got a hydrogen. ठीक है, the double bond is attacking the hydrogen. You get a positive charge over here और ये आ गए दो bonds. ठीक है. So basically there's a CH3 over here now and there's a positive charge over here. What are you going to get? Yes, yes, Rudra, it is. It is Wagner-Mirvin rearrangement only. And ये same mechanism हमने किया था when we were doing the NGP by a carbon-carbon double bond also, right? So yes, you will get the carbocation same intermediate. और यहाँ पे इस वाले को क्या करा दो? Yes, this bond can directly jump over here to give this kind of a carbocation. Okay? Yes, rearrangement, carbocation rearrangement, very similar to NGP which I had made you do. अब इसको रोटेट करो. All right, योगेश, देखो simple rotation तो ऐसे ही आता है. That you keep this carbon over here and this is your methyl और ये बन गया यहाँ पे positive. ठीक है, right? Yes. Now, next thing is the Cl has to attack. कहाँ अटैक करेगा? Above the plane attack करेगा, below the plane. Whenever you have these bulky methyl groups on this apex carbon over here, क्या करना चाहिए? The Cl minus is going to attack from below because of the bulky methyl groups. So that is why endo attack is more favored. Endo attack is more favored than the exo attack. This is your major product. ठीक है, answer is option A. Now, yes, योगेश, कौन सा बॉन्ड रोटेट, कौन सा बॉन्ड माइग्रेट करेंगे जिससे ये वाला प्रोडक्ट आए? यस, दिस बॉन्ड माइग्रेटेड टू शो यू कि चलो ठीक है, यहाँ पे कार्बोकेटायन था. दिस बॉन्ड इज माइग्रेटिंग टू गिव यू दिस प्रोडक्ट विच इज बेसिकली द इनैंशियोमर ऑफ ऑप्शन नंबर ए. ठीक है, और कोई पॉसिबिलिटी नहीं है ना? है क्या? नहीं है. टू गिव दिस, टू गेट दिस प्रोडक्ट एक ही है, इनैंशियोमर ही बनेगा. ठीक है, चलो चलते हैं अभी गाइस. 7 questions are done and also we have done Wagner-Mervin rearrangement in carbocation reactions in the plus classes. Okay, many more stuff we are doing in the plus class guys. अगर आपको join करना है तो आप join कर सकते हैं Unacademy Plus and there are a lot of benefits. Weekly test, doubt clearing session, unlimited access for all the educators classes under just one subscription. Courses are very structured और ऐसा नहीं है कि 2-3 courses है, plenty of courses. All right, and live classes, free live classes, and you can also download the PDF. The plus और iconic में क्या है? Personal guidance है, test analysis, expert guidelines by workshops. ठीक है, और study planner तो है ही. All right, so all of these things, all of these benefits you are getting in your Unacademy Plus and Iconic. The preparation is going on in full force. और बाकी क्या है? फिलहाल के लिए guys, I am giving you a lot of free classes with a lot of good examples. So if you don't want to join, at least do the free classes. And if you want to do full preparation, you can join Iconic or you can join Unacademy Plus as well by selecting any of these packages and using the code Jagriti S Live. ठीक है, ये मेरा कोड भी, ये भी मेरा ही कोड है Jagriti S Live, so that you can get a 10% discount. Okay, all right guys, so yes, it was really good having a practice session and I see कि आप लोग भी काफी अच्छे answers दे रहे हो. More nice answers I am expecting in the next session. बाकी पूरे बहुत सारे session होने वाले हैं. I'm going to see you in another session. If you have not subscribed to this channel, please do. और अगर अच्छा लग रहा है तो like share भी कर दो. ठीक है, चलो. Yes guys, take care of yourselves. Bye everyone.